So today I will discuss the next concept, very important concept called duality. From one linear program, we can derive another linear program. The optimal values of the objective function in both the problems are the same. After this standard form, you can convert this into dual of this primal problem. Hello everyone, welcome back to my new session on operation research. In my last session, I have discussed about degeneracy in linear programming problem. So today I will discuss the next concept, very important concept called duality. So what is the meaning of this duality in linear programming problem? So already you have studied about simplex problem, big M method, two-phase method and degeneracy in LPP also. So what is this duality in linear programming problem? Let's get started now. So concepts of duality definition. The duality in linear programming states that every linear programming problem has another linear programming problem. So for every linear programming is having another linear program to relate it to it, and this can be derived from it. So from one linear program, we can derive another linear program. And the original linear programming problem is called primal problem. So when you are applying the duality problem, so the original problem is called as primal problem. Original problem is called as primal. Primal means it is original, and while the derived linear programming is called dual. So original is called as primal and derived problem is called as dual. Primal is original and dual means it is derived programming problem. So in every linear program, we can get the new linear programming problem. The original problem is called as primal and the derived problem is called as dual. And what is this duality theorem states that if either the primal or the dual problem has a finite optimal solution, if the problem has a finite optimal solution, then the other problem also has the finite optimal solution, because from original primal problem we are getting the derived dual problem, right? I'll repeat, if either the primal or the dual problem has a finite optimal solution, obviously then the other problem also has the finite optimal solution, because from virginal only we are getting the dual problem. If virginal has a optimal solution, finite optimal solution, obviously the derived one also will get the optimal solution. And the optimal values of the objective function in both the problems are the same, that is max z x is equal to min z y. I'll repeat, the optimal values of the objective function. So objective function means it can be minimization or maximization. So in duality theorem also you will get the same objective function for primal and for dual. So here example, if your primal is max zx, your dual is derived one is max changes to min and z is common and x changes to y. Listen carefully. So if your primal problem of the objective function is in the maximization, that the dual of this is minimization, and the original variable is x, the dual of this variable is y. This is called as duality problem. If your primal is maximization, the dual of this minimization. If your primal is minimization, the dual of this maximization. And x primal is x means dual of this variable is y. If your primal is y means dual of this variable is x. That's it. So this is about your duality theorem. So I will explain with an example of this duality theorem. First I will write the formula. Max x z is equal to sigma j is equal to 1 to n Cj into xj. Consider a11 x1 plus a12 x2 plus a13 x3 plus and so on a1n up to a1n xn less than or equal to b1. Consider a11 x1, a12 x2, a13 x3 dash 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 up to a1n xn is less than or equal to b1 because I am solving for maximization. Less than or equal to b1 and again a12 x1 plus a22 x2 plus a23 x3 and so on up to a2n xn less than or equal to b2. So now I have considered a11 x1 to a1n xn. It's less than or equal to b1 and again a12 x1 up to a2n xn is less than or equal to b2 and so on a11 x1, a12 x2 again a13 x1 and a14 x1, a15 x1 and so on up to am1 x1 up to am1. I am starting from a11 x1, a12 x2, a13 x3 and so on plus am1 x1, a11 to am1 plus am2 x2 plus and so on up to amn xn less than or equal to bm. You just observe this. Here I considered a11 x1 to a1n xn less than or equal to b1 and a12 x1 to a2n xn less than or equal to b2 and you just observe this LHS. So a11, a12, a13, a14 up to am1. I have considered it is am1 and you just observe this RHS b1, b2, b3, b4, b5, b6 up to bm. So this is your RHS and this is your LHS. So this is your original problem. So this original problem is called as primal problem. So original problem is primal problem and how do you convert this primal to dual? Dual of this problem is max z changes to min zy. Max z x changes to min zy. So what is the dual of this problem? So dual of this max is min y z is equal to sigma I, j changes to I, m changes to n and c changes to b and j changes to I. So this is your min of this max. So this is your dual of this primal. So primal is original, dual is derived one. So here how to convert this original problem to duality. So here you just observe this LHS and RHS. Your RHS value will move on to the objective function. So now how to convert this original primal problem to dual. So here you just observe this LHS and RHS, all the B values will changes to C1, C2, C3 up to Cn. So dual of this problem is C1, C2, C3, C4 up to Cn and your LHS is changes to, here I have A11 X1, it is changes to A11 Y1 and A12 Y2 and A13 Y3 and so on up to A1 N Y1. You just cross verify this. This is my primal and this is dual. This is primal and this is my dual. A11 x1 changes to A11 y1, A13 x1, A13 y3 up to AM1 x1 to A1n y1. So this is your primal to dual. All the x variable changes to y variable and all max changes to min z dash. So this is your primal to dual conversion. This is called as duality theorem. So let's understand about the formulation of dual from primal. Before solving for the duality, the original linear programming problem is to be formulated in its standard form. So here, before solving for duality, so all the maximization and constraints, example x1 plus x2 plus x3 less than or equal to 3 and 3x1 plus 2x2 plus 5x3 less than or equal to 5. So now it is in a inequality form. You have to convert this into standard form, and standard form means all the variables of the problem should be non-negative. So here all the variables of the problem, that means all the RHS value should be non-negative, and convert the given problem into canonical form where all the inequalities are made into less than or equal to if it is maximization. If it is maximization problem, all the inequalities has to be converted into less than or equal to, and or all inequalities are made into greater than or equal to if it is minimization. So already I have explained this concept in simplex method, big M and two-phase method. So same thing we are applying in dual also. So all the maximization problem, all the constraints should be less than or equal to. For all minimization problem, constraint should be greater than or equal to sign. And change the objective function of maximization in the primal into minimization in the dual and vice versa. So here all the objective function, example I have 5x1 and 6x2. Maximization is equal to 5x1 plus 6x2. So in second step, objective function of the maximization in the primal into minimization in the dual and vice versa. So here the objective function is 5x1 and 6x2. All this primal. So now it is in a primal. For converting into dual, all the maximization objective function will come to the RHS value. So next I will show you with an example. And the third step, the number of variables in the primal will be the number of constraints in the dual and vice versa. The number of variables in the constraint will move on to the dual of the constraint. And next step, the RHS of the constraints become the coefficient in the objective function. Example, here I have A2 RHS value 3 and 5. So this 3 and 5 will move on to the coefficient of this objective function. Example, so dual of this problem is 3 max changes to min z dash is equal to 3x1 plus 5x2. Listen carefully. So this is my primal problem, that means original problem. So here in RHS I have 3 and 5. All this RHS value will become the coefficient of the objective function. So this 3 and 5 is become the coefficient of the objective function, that is called as dual. So this is primal and dual of the objective function. You just observe this primal objective function and dual objective function. So RHS value will become the coefficient of the maximization. So coefficient of objective function become 3x1 plus 5x2. So this is your primal problem. So the objective function have converted. So now how to convert this into dual? So next step, columns in the constraints of the primal becomes the rows in the dual. Listen carefully. Columns in the constraints of the primal becomes the rows in the dual. Example, columns. Here in constraint I have 3 columns. x1 3, I have 1 3. Objective function I am telling. So objective functions of columns x1, 3x1, x2, 2x2, x3, 5x3. So I have list all the columns. So now I will shift this coefficient of objective function. I will write it in a matrix format. Coefficient of x1 is 1 and this column will changes to the row, and again this column 1 and 2, again this column 1 and 5. In primal problem, we have 3 variables, coefficient of x1, x2, x3, coefficient of x1, x2, x3. So all this column will become rows. So 1, 3, 1, 2, 1, 5. So this column will become row and this column, second column become row. This third column become row. So this is called as duality. So now it is in a original format, that is called as primal. Primal is converted into dual. So all the RHS value will become the coefficient of objective function. All the coefficient of objective function will become the RHS value in dual. And all the columns will move on to the rows. All the columns will become rows. And this is called as duality problems. So now we'll understand the concept of primal versus dual. So very important question for 4 marks. Primal and dual. So primal is maximization. If your primal is maximization Z, so what is the dual of this? So min Z dash. And if your primal is min Z, so obviously dual is max Z dash. And coefficients of objective function. So if your coefficient of objective function in the dual will move on to the RHS of constraints. Example, already I have told you that 5x1 plus 6x2. So this is my coefficient of objective function. So this in dual form. Dual form is this coefficient of objective function will move on to the RHS of the constraints. So here example, if you have x1, x2 will become 2x1 plus 3x2. So it is, so here you just observe this. This is primal and this is dual. All the coefficient of objective function will become the RHS constraints. And nth variables is in unrestricted. So that I will explain while doing the problem. Nth constraint is an equation. And no feasible solution for maximization primal. So it is unbounded solution. So after converting from primal to dual, you can go for graphical method, simplex method. So you will get the unbounded solution. After converting from primal to dual, so you will get, if it is no feasible solution, so usually you will get unbounded solution in dual. And finite optimal solution, so obviously here same as primal. If a primal has a finite optimal solution, in dual also you will get same optimal solution. So this is about your primal and dual. So now let's understand with an example. Now this is in a primal form. So now I will convert this into dual form. You just observe this, this is maximization, and just check the RHS, it is positive only, and here all the constraints are greater than or equal to sign, greater than or equal to, but this is in less than or equal to sign. So this you need to convert it into greater than or equal to sign, because all the constraints should be same, and this converted into standard form. So now I will convert this third constraint into standard form. So it will become minus x1 minus x2 greater than or equal to minus 9. So this is your third constraint. So now what is the dual of this primal? Find the dual now. So max z changes to min z dash. Max z changes to min z dash, and the coefficient of this objective function 4 and 3 will shifted to this position called RHS of constraint. The coefficient of this objective function will become the RHS value of the constraint. So 4 and 3 4 and minus 3 is your RHS value. So all the greater than symbol will changes to less than or equal to, less than or equal to. Keep in mind, all max will changes to min and all the coefficient of objective function changes to coefficient of the RHS constraint. So now constraints values are, RHS constraint value is 4 and minus 3. All greater than symbol changes to less than or equal to and less than or equal to. So now you just observe this constraints. So here I have 2, 5, 3, 7, x1, 4, x2, 4 and 9. So all this column value will become row values. So write it in a matrix method. So 2, 3, 1, 4. 2, 3, 1, 4. All this column become row. And 5, 7, 4, 9. 5, 7, 4, 9. So all this column have written in a matrix form. Now you can find the constraint values. It is 2x1 plus 3x2 plus x3 plus 4x4 and 5x1 plus 7x2 plus 4x3 plus 9x4. And still we have to write the objective function. So just observe this RHS value 6, 5, 9, 12. So this is in a column form. I'll write it in a row wise. So row wise means all the coefficient of objective function will move on to the RHS constraints and all this RHS value will shift it to the objective of this coefficient value. So it is 6x1 plus 5x2 plus 9x3 plus 12x4. So now this is in a duality form. This is your primal to dual conversion. First you have to convert this into standard form. So here all the constraints are greater than sign, but here one constraint is less than or equal to sign, that I will convert it as greater than or equal to sign. So multiply by minus 1. So I have converted this into standard form. After this standard form, you can convert this into dual of this primal problem. So all the objective coefficient of objective values will become RHS value and all the RHS value will become the coefficient of this objective function and all the column values will become the row values as a matrix method. All the columns will become row values as a matrix method. So this is your constraint now. So before that we got only 2 variables in one constraint. So now observe this, we got 4 variables in one constraint. So in first constraint I have x1, x2, x3, x4, but in previous primal problem I got only 2 constraints called x1 and x2, x1, x2, x1, x2, x1, x2. Now it is x1, x2, x3, x4, x1, x2, x3, x4. So we have 2 constraints and here I have 4 variables. So all the primal is changes to dual form. So this is about your primal to dual conversion. So definitely there will be a 2 marks question on this concept. Explain primal or dual or explain duality theorem. Sometimes you will get this problem for 2 marks or 4 marks. So this is called as duality problem. So primal changes to dual. So all the objective function will become the RHS of the constraint and RHS of the constraint will become the coefficient of this objective function. So here you can use the matrix method for converting the primal to dual. This is very simple concept. Easily you can score in primal to dual conversion. So sometimes you will get less than or equal to, greater than or equal to or equal sign. In constraint, sometimes you will get less than or equal to or greater than or equal to or equal sign. So in big M method and two-phase method, if you get equal sign in a constraint, so we were adding the artificial variable. But in primal to dual conversion, you are not supposed to add this A1, A2. You're not supposed to add this artificial variable in primal to dual conversion. So here we are not adding any artificial variable in primal to dual conversion. We have to convert this into standard form. So we have another method for converting primal to dual when you get equal sign. So second method we have to do in primal to dual when you get equal sign. You are not supposed to add artificial variable in primal to dual conversion. Please keep in mind we are not using this artificial variable in primal to dual conversion. We have to use second method for primal to dual conversion. So I will discuss some more problems on primal to dual conversion. Thank you. Take care. Bye-bye.